Hey guys, this is the kind of first intro piece to the second lesson. So in the book, this is kind of a combination of the first two lessons, so that's why I put that. But like in Schoology, this is like the kind of intro lesson to lesson two, if you will. So trig functions are no different than any other function. So we've had quadratics, we've had cubics, we've had absolute value and square root. They all follow this basic process where like this number is always the opposite of like what you're looking for, and that moves it like left or right. This number moves it up and down. So we're going to be talking about those kind of things. So the first letter I want to focus on is A, because we talked about that the other day. So A, that is going to affect our amplitude. And so it's going to stretch your graph. So if a regular graph goes like this, it's going to stretch it by a certain factor. And so if it were like 1/4, it might be actually smaller, but it does different things to that. So let me kind of write the stuff next to it. Okay, so here's everything I've said about it. So if A is like 2, then that's going to be a stretch. If A is 1/2, that's going to be a shrink. So it'd be like 1/2 your normal size. Also, don't forget, we've talked about this too. If A is negative, it's going to flip it. So instead of going like 0, 1, 0, -1, 0, you would go this way. Okay, so we also talked about B. And while A affects your Y values, B is going to affect your X values. So what B does is, if I have a regular graph like this, it is going to compress it. And so I'm going to write down everything we need to talk about here. So if you'll notice B, and it's always, it doesn't matter which function it is, it's always opposite. And people always have kind of a hard time wrapping their mind around that. So a shrink is what we're used to. So that's what I just did. So like it's going to shrink it or compress it if B is bigger than 1. So I think we had like Y equals cosine of 3x or sine of 3x or something like that. So it compresses it and makes those tighter together. But if I stretch it out, that's going to be like B equals 1/2 x, or sine of 1/2 x, or cosine or whatever. So that's going to stretch it out. Okay, the next thing I want to talk about that we have not talked about yet is H and K. So H is going to affect your X values, and K is going to affect your Y values. So let's go back. We are familiar with this with other functions. So these are those X's or H's and K's. So X, the H applied to the X moves left, right, and the K moves up and down. So that's what we're going to talk about here. Okay, so just don't forget that the H is connected to the X, so X's are always do weird things. So it's always opposite. So when it's a plus, you're going to go left. When it's a minus, you're going to go right. K's are just good to go. So if it's a plus, you go up. Minus, you go down. You will see H's called a horizontal shift, and sometimes it's called a phase shift. So if you see the word phase shift, that's what it's talking about. It's talking about that H. How far left or right did it go? And then the K is called a vertical shift. So let's go ahead and start with this. And so I have A and I have K. So I want you to notice that both of these, A and K, both deal with the Y values. So we're going to affect the Y values. So you're always going to think order of operations. So you're going to do multiply first and then subtract when you're affecting your, like if you have two different things that you're doing. You'll never have more than 2 to 1 letter. So you can at most have 2 things that you're doing to X and 2 things that you're doing to Y. But notice here, there's nothing that we're doing to the X's at all. We don't have an H and we don't have a B. So we're just going to leave the X's alone. So I'm going to create my table. So we have sine. So these are the 2 that I start with. And now I'm going to take the y's and I'm going to multiply everything by 3. So 0, 3, 0, negative 3, 0. Now I'm going to subtract 4 from everything. So I have negative 4, negative 1, negative 4, negative 7, negative 4. So I always like to, like, when I'm done, I always look for the x and y value that I'm going to use and then circle it. And now I'm going to graph it. Okay, and this is what my graph looks like. So let's talk about the amplitude, the period, the domain, and range. So go ahead and list those as well. Okay, so I was running out of room, so I had to do this backwards. The amplitude is 3, and remember we get the amplitude right there. It's always positive. The period is 2 pi because the x values weren't affected at all. So that's going to stay the same. The domain, I went ahead and just put both of these in interval notation because I was short on space. The domain is negative infinity, positive infinity, and the range, I'm going to look here, down here, my lowest number was negative 7, my highest number was negative 1. So that's my interval notation. So go ahead and try 2 and 3 on your own and see what you can do with that. And for these, let's just, for the sake of time, just create the table. Okay, so on this one, well, this is kind of like when we did the other day. So this affects my y value, so I multiplied everything through by negative 1/2. And this 5 affects my x value, so I divided everything by 5. So if I were listing the period, the time period now would be 2 pi over 5 to complete a cycle. Okay, so this is the first time that we had an h. So remember, this affects your x values, and you are going to subtract pi over 4 to all your x values. That is the only thing we're doing. So my y values are just going to stay like that. So I'm going to take all of these and subtract pi over 4. So see if you can do that on your own, and if not, we can talk about it. So a couple of things I want to point out. You can do a lot of this in your calculator. So if you just look at this as like I'm subtracting 1/4 and then, sorry, 1/4 and then add the pi in. And then add the pi in at the end, you can get your calculator to do a lot of it. So here I have like 1/2 minus 1/4. Goodness gracious, 1/4. Okay, and so that ends up being a positive 1/4. So I'm going to say pi over 4. Also, notice that everything is perfectly symmetrical all the time. So let's go back over here. I have 0, 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. So here I have negative 1, 1. So I'm going up by 2, 3, 5, and 7. So have that kind of help you. I actually, I made a mistake here and I did 2 pi over 4 instead of 3 pi over 4. So I was able to catch myself because it didn't fit into the pattern. So I want to jump down to, let's do number 6. So the first thing that I would do with number 6 is get y by itself. And I think you would know that if you're in an algebra class. But I just wanted to, it's weird. I know all of this is new. So I want to see what you can do with this one. Okay, so the first thing I noticed is that was cosine. So I did the 1, 0, negative 1, 0, 1. And I saw that the y value was affected by 2 things. So I needed to multiply by negative 4, and I needed to add 3. So you do the negative 4 first, and then the add 3. So I'm done with my y values. The next thing I have to do, my b is actually 1/2. So remember your b, you always divide it. So when I divide by 1/2, I'm going to multiply my x values by 2. So I'm going to take all of my x values and multiply them by 2. So notice the pattern. I have 0, 1 pi, 2 pi, 3 pi, and 4 pi. So those are my 2 answers. Okay, so now we're going to focus on the whole shebang. So I think we're really good at this. It seems a little bit too simple. Let's go down to number 4. So we'll start here. So I always get a game plan. So I have 2 things affecting my y's and 2 things affecting my x's. If you notice, the things that affect your x are always surrounding it. It's like always right next to the x. So these two things, and it's always going to be opposite. I'm going to divide by 2, and then I'm going to add pi over 2. Here, I'm going to multiply by 4 and add 3. So go ahead and see if you can make the table. Okay, so this is everything in my table. So this is the work I did to get my y values and the work I did to get my x values. So on this, let's look at this one, for example, to get 3 pi over 4. In my calculator, if you're not good with fractions, I would say 1/4 plus 1/2. Get your fraction and then add a pi to it. Okay, go ahead and do the graph and then answer the domain, range, period, and amplitude. Okay, so this is my graph, and these are my answers. So before now, we've never had two different things that we're doing. Oops, sorry, no, that's two different things that we're doing to our x's. And so it was always just like that last value, but if you shift it, it's not the last value. So the formula for period is 2 pi over whatever b is. So if you look, our b was 2 right there. So that's why it's pi. You'll always find it in your chart before you shift it right there. That's where you can find your period as well. So there's 2 more. I'm just going to work through it on my own and then just show you guys the results. Okay, so here is everything. So go ahead and double check mine. You might need to push pause and make sure that you have everything I do. Okay, and I'm going to do this one more time. Okay, this is the last one. Just be careful. The amplitude's always positive, but other than that, this one's pretty straightforward. And that is the end of lesson 2, part 1.